So hello and welcome to everybody joining us for this Elektor webinar with Arduino, where we're going to be looking at unlocking the power of MicroPython on your Arduino. I'm your host, Stuart Cording, the electronics reporter. Today, my guests are Sebastian Romero and David Cuartieles. The only problem is we've lost Sebastian in the meantime, so we'll try and get him back into the system very shortly. So before we get started, you are probably, if you're not watching on YouTube, you're probably entering the show on ClickMeeting. That's the platform we're using. And just to give you a quick update of how this system works, on the right-hand side, probably you'll find an area for public chat that allows you, our audience, to chat amongst yourselves. Tell everybody where you're watching from, where you're participating from, what you're interested in. And also what your involvement is in Arduino, in MicroPython. Have a good chat with each other. If you have any questions that you want to pose to our guests, we're going to do a Q&A section at the end. Please put questions in the Q&A area, because then later on we'll be able to pull those up onto the screen and get answers to them, or guide you to resources where you're going to find answers. So before we get started with our discussion and to give you an opportunity to win some great prizes, we're going to tell you about our giveaway. We've got 5 Arduino products all ready to go. There's a link going to appear at the top of the page where you can enter in the competition. We've got an Arduino machine control board, that's a PLC controller, an Arduino Nano 33BLE Sense, an Arduino Nano RP2040 Connect, an Arduino Portenta H7, as well as an Arduino Nicola Vision. So click that link at the top of the page, go to the web page, put in your information, and the code word to participate today is snakes. That's right, the code word is snakes. So I'm going to come over to David to start with. Firstly, hi David, how are you doing?
Yeah, it's all good. Yes, the typical Swedish winter day.
A Swedish winter day. We've got a Munich winter day today, and it's just blowing around my house here. So I know I can feel your pain. It would be nice if it was a bit warmer. I'm looking forward to spring.
Yeah, no, we had a very similar, end of the winter day here.
Yeah, exactly. So yeah, roll on summer. So one of the things I wanted to start with was to ask you about the relationship that Elektor has had with Arduino over the past few months. We've been working together very closely. For those of our people who are members of Elektor, you may have seen this magazine. This was from November-December timeframe. Elektor magazine number 518, and we worked together with Arduino on all of the articles. In fact, Arduino took over the magazine and put all the information in there. We'll show you some of those things as we go along. So what were the highlights of partnering with Elektor these past months for you, David?
Well, it was a very good relationship, I have to say. It was obviously Elektor is pretty good at producing magazines, I have to say. But no, it helped us taking a snapshot of our community, 16 years in the making, which is really good. We could look back. We took the opportunity of interviewing some people we've been working with for so many years, and Elektor made a great job in putting this together in both the magazine and the online edition, the extra materials. We had so much material. We had to make, I don't know how many extra pages, 32 pages or something. Really, really crazy.
Exactly.
Yeah, for me, it was really good. I got a chance to talk to people that I had never had a chance before, and that have been very important for our community. For example, Tim Barras, who originally made the Mozzi library and created a whole way of thinking about how to produce sounds with microcontrollers in a very simplified way that is being ported to other platforms. So, or forcing our head of firmware to develop some funky things for us, like running MS-DOS on Portenta. That was also an interesting thing. Having the magazine as a milestone really puts people to work towards it, and it was very interesting. So it was very good to have this work with Elektor.
Yeah, I love the magazine as well. There were some really diverse projects, and one of the things I liked was in the middle, I cover Elektor engineering insights for the team and look at more sort of the industry angle, and you had all those case studies in the middle, which was really nice to see how Arduino is sort of deployed in various areas and what it's enabled. Now, when you were last on our show Lab Talk, I think you were talking to Jens, you challenged the community to build a Doom game controller with the Arduino Portenta. And what we wanted to do was catch up and find out if there was any movement on that. And if not, is that competition still open, and what do people need to do?
Of course, I mean, to the first person that submits the Arduino Doom, of Doom running on Arduino Portenta H7 with a game controller, which means like some sort of control, whether you build it with buttons or you connect the computer keyboard to play the game or whatnot. Basically, it's a software hack you have to do, because we provide everything to that, the interaction part. To the first person submitting, I will make sure to provide that person with a nice prize. So far, there's been no brave programmers joining us, but I'm pretty sure there's a whole lot of people out there that are waiting for an opportunity to make this happen.
I think so, and we've got several hundred people online today, and they're from all over the place. So I'm sure there's somebody out there who's going to take up the gauntlet. There's 500 people online watching at the minute. So one of you, please get in touch with David, show him how you can play Doom on the H7 complete with controller. So the next big event on the calendar is, of course, next week, Embedded World in Nuremberg, Germany. And that's the place where anybody and everybody who has anything to do with embedded systems development is there, showing off the latest microcontrollers, the software that goes around it, the electronics that goes around that, development tools, test and measurement equipment, the who's who of the industry. Is that a trade fair that you attend? Will you be there, and do you enjoy such trade fairs?
Yeah, so Arduino is typically going there. Arduino goes to the biggest fairs lately, especially to promote our professional line of tools, because it's a place where to meet the industry, right? It's a place where the medium, small to medium and large companies go and both present their work, but also look for tools to fulfill their needs. So obviously Arduino is going to be there. I will personally not be there, so please don't look for me.
Okay.
But a lot of people from Arduino, and very likely our CEO, are going to be present. So, take the opportunity, pass by our place, check our stuff. I'm pretty sure you will be impressed.
Yeah, sounds good. Well, very good. We'll actually, we're going to pull up the hall and stand number as well, unless one of you've got it to hand. Maybe one of my team in the background can send me it in the chat so as we can guide everybody to the correct place. Well, thanks ever so much, David, for the update. It's great to see you again. We saw you last time Electronica for our live stream. We'll also be doing a live stream from Embedded World on the Tuesday, that's the 14th of March, where we'll review at about 5 o'clock all the stuff we've seen during the day at Embedded World. So there's something else to look forward to there. Super, thanks very much. So before we carry on to Sebastian, today's topic, as we said at the beginning, is talking about Arduino in the context of programming it with MicroPython. And to get an understanding of what the community is doing with MicroPython at the minute, we have prepared a little survey. If I can just find out what this survey is. There we go, the survey's popped up. So we'd like to ask you, have you used MicroPython? Either no, I've not used MicroPython, yes, I've used it with Arduino, or yes, I've used it with another board or platform. So we're just going to give you a moment there to do that. And in the meantime, while you're having a little click through, there's plenty of you to click. So it's going to take a little while until we've gathered up all the results. We'll move on to Sebastian. Welcome to the show, Sebastian. Great to see you.
Thank you so much, Stuart. Happy to be here.
So for the people who haven't seen the magazine, we've obviously talked in the past. I interviewed you for the magazine, but maybe for everyone else for whom you are a new face, you could just give us a quick introduction to who you are, your role at Arduino, and what your background is and relationship to Python.
Right. So I actually have a background in both software engineering and interaction design. And that's what I got to practice also at Arduino. So I started out in the design team, looking into crafting, enthralling user experiences, and then sort of turned to creating learning experiences from the content point of view. So I was in the content team for quite a while. And now I I'm going to move on to something new, exciting, which is application development, so user-facing library development. And Python has been something that was sort of a partner for me since the early programming beginnings. And I was very excited to see that coming to the world of microcontrollers. And as it looks like, I'm not just the only one being excited about that. We have 450 almost people who also think that's an interesting topic. So super excited to talk about that today.
Yeah, exactly. No, we've got the results in. We've about 80% of you have voted, which is fantastic. Thank you for participating. And a large percentage of you, about 50% of you, haven't actually experienced MicroPython yet. The remainder have at some point or other, a small proportion with Arduino. And it's probably because it's on Arduino, it's relatively new compared to some of the other development boards out there. So let's change that. Let's give you some ideas about how MicroPython is integrated. I'm going to pull up Sebastian's presentation so he can take us through some of the background concepts on MicroPython, where it fits into the Arduino environment. And he's also going to take us through some practical examples as well. And we'll do our best to fit in as many as possible. And as we're going along, I can see that already some of you have popped in a few questions in the Q&A. So let us know, let us know what your questions are, and we'll come to them as quickly as we can as we move along. So Sebastian, over to you.
Fantastic, thank you, Stuart. And I'm happy to see these results because I kind of anticipated that a lot of people would not be experts yet in MicroPython. So this is really geared towards people who have been dabbling with Arduino, but have not yet taken the leap to apply these things with MicroPython. So today I'm going to give you a bit of an overview of what you can do with the things that we offer. So the focus is going to be on applying the concepts known from Arduino to MicroPython, but I'm not going to go into detail on the Python programming language itself or Arduino fundamentals. But we have a ton of learning materials on our website. So if that's something you want to do, you definitely should check that out. The link to that is on the last slide, so you will see that. I guess all of you know what is Arduino, otherwise you probably wouldn't be here, but just as a quick summary, it's basically a complete platform that helps you to easily develop your hardware solutions. And what's very exciting is that we have a huge community of millions of people that not only provide you with support and inspiration, but they also have created thousands of libraries to support almost any module or sensor or actuator that you can think of. And you will see an example of that in my session today. So the other thing is MicroPython. So what is that? It's basically a software implementation of the Python programming language, but it's like slimmed down such that it can run effectively on microcontrollers. And what I think is really cool about that is that it really enables the people who want to build embedded IoT solutions in an easy way with a familiar language, or at least a language that's easy to learn. And that brings me to the benefits of MicroPython. So in my opinion, it's easy to learn, especially if you already know Python. It reduces drastically sometimes the development time because it's very, very easy to test your code because it's an interpreted code. More on that later. It increases productivity because it comes with a range of built-in libraries. One example maybe would be to parse JSON. I'm going to show how to do that also. And it increases portability. It also applies to the classic Arduino, but MicroPython also is built as a generic abstraction API that runs on different microcontrollers. And last but not least, because it's so easy to test your code, it's actually also easy to debug your code interactively by inspecting the data, executing functions, and so on. Now, if you want to do this with Arduino hardware, this is what we currently offer. So a couple of different boards with different capabilities. If you want to know about these capabilities, please go to our docs website and check them out. In the demo today, I mainly use the Nano or P2040 Connect. And for one quick example, if we get to it, I will use the Portento H7. Now, For developing MicroPython, in theory, you can use any text editor that you want, but there's a couple of more advanced options or easier options maybe. We've been previously using the Arduino IDE for the developing classic Arduino sketches in C and C++, and you can still do that. But if you want to do MicroPython, now we have something extra. It's an experimental IDE that's very simple to use, that allows you to develop the code and test it on the device. And then there's yet another one, which is called OpenMV IDE. So we have been partnering with OpenMV to support our boards with their infrastructure. And this IDE is specifically geared towards machine vision applications. I'll explain a little bit more later on. Then how does that actually work? So in Arduino, we have sketches, and then in MicroPython, we have these scripts. So I quickly wanted to explain how that kind of comes together. So a sketch is Arduino terminology for firmware. So you have your code, and then it gets compiled into a binary, and then it needs to be flashed onto your board with some special tools. And inside that sketch, you would usually find the familiar setup and loop functions that you would populate with configuration logic. And in the loop function, you would execute whatever your application contains. On the other hand, in MicroPython, it's a bit different. So we also have a firmware, but the firmware is the MicroPython runtime. So you flash that once, and when it's on the board, it just runs and executes your scripts. And the scripts, as I said, are text files, and they get interpreted into, and then transformed into bytecode. Uploading them is as easy as copying them onto a mass storage device, which mounts when you connect the board that has MicroPython installed. And then it runs through your script once, unless you put an infinite loop inside, which is different to the Arduino sketches that have these loop functions, this loop function. Now, what happens when you power the board that has MicroPython installed? This is important to know. So there's two files that you should know. It's bootpy and mainpy. And bootpy basically is the first thing to be executed, and there you can put a code that, for example, configures your board. It could, for example, connect to a Wi-Fi or something like that. And the mainpy file is what contains your actual application. Now, how do you test applications? And that's a little bit, let's say, more work on the Arduino side currently. If you have your sketch and if you want to test if it works correctly, then usually either you have an actual debugger, like a hardware debugger, or you end up using the serial monitor. And if you want to do this more or less interactively, you will need to write debug code that accepts some commands and then executes your functions, and that allows you to inspect what's going on. You could maybe think about adding external physical buttons to trigger these kind of things, but it's a little bit, it's a lot of work to do that. On the other hand, in MicroPython, you have something called the REPL, which means read, evaluate, print loop, which is nothing more than an interactive prompt. So it's an interactive kind of command line prompt that you can use to inspect the code, to run functions, and to modify data. It's a very powerful thing. I will show how that works. Now, how do you actually install MicroPython? And currently on our website, you find instructions on how to install the vanilla. That's how I call the sort of official MicroPython distribution onto the Arduino boards. I've been lately playing around a bit with the tools. I made an experimental tool that allows to automatically download the latest firmware for your Arduino board and then flash it to the board. It currently runs on macOS, but with a little bit of modification, probably on Linux also. Now, when you install MicroPython, it's, as I said, it launches these mass storage device. So it looks like you plugged in a USB stick where you can upload your Python files. Then we should talk about libraries, because as I said, there's almost for anything you can think of, there's a library. So you want to know how to install them. And there's two ways. One easy way is that you just copy the files onto the mass storage device. You have them then available, or you use something a bit more sophisticated, which is a tool called MIP, which installs library packages, and you can execute that from your computer. If you do that, then you need to use it together with this tool MP Remote. There is documentation on the official MicroPython website on this if you want to check it out. But anyway, you connect to your board and then execute the install command, and you pass it either a GitHub repository or a specific file within that, or even an official library from the official repository. But what's even more awesome is that that works also from the board itself. So if you have a network capable board, it can dynamically download these libraries as you go. So that's super cool. For that, you would need to use the MIP package, and then you can execute the install command and install stuff on the go. So much for the introduction. Now let's have a look at how you actually use MicroPython. And I was thinking, what would be a good way of doing that? So I made a very small project, and I was surprised how little effort it was to get it up and running. So I want to quickly walk you through sort of the needed components for that. But before that, let's have a quick look at this REPL feature that I talked about. So it's basically this prompt that you see there in this dark black part at the bottom right. And if you run a script from the IDE, it would execute once, but it would then stop and give you the possibility to build upon that. So it provides you with the same data context, and then you can inspect and edit the data. One thing that I need to say, because I've seen people getting confused, is that when you hit run, it doesn't actually copy anything to the mass storage. So it doesn't write to the main py file. It just executes it on the fly. So it's a temporary kind of thing. This project that I want to quickly walk you through is a music player, and I implemented that with a breakout board that allowed me to connect Grove modules. And what it has in terms of features is that it has a screen that shows you the current track. It shows you the volume in an LED bar, and it allows you to change the volume with a potentiometer. I've been using a rotary encoder to skip the tracks, and it has a play and pause button to pause the music. And what's really cool is that all of that glue code together was just 100 lines of code. But before I start with that, I quickly want to show you, as promised, this REPL thingy. So let me see if I can fire this up. Yes. Okay, now you should see my screen. And in here, I have the same as I had on the slide. So it's basically just one variable that gets set. And if I run it, I enter this REPL interactive prompt, and now I can print it. So if I type print foo, it will spit out the value. I can modify it. For example, foo equals, or I just multiply it by 2. And then if I print it again, now the value has changed. But you can use that for all sorts of things. So you can instantiate new objects, you can execute functions on these objects, and so on. So a very powerful thing to test your code. All right. So where are my slides? Oh, there we go. Cool. So the first component that's sort of the hello world example is the LED. And you've all been blinking LEDs, hopefully. So in Arduino language, you use digital write, whereas in MicroPython, it's a more object-oriented approach. So you would instantiate an object here and pass it the pin number. So here it's pin number 6. And then you specify it as an output. And then all that's left to do is that you turn it on with the on function. And then here, what you've known as delay in Arduino language, we now have to use a sleep function from the time module. So you turn it on, wait half a second, and turn it off. So quite simple to do. Then there's the good old in Arduino language, we call it analog write, but what it actually is pulse width modulation. And if you don't know about that, don't worry. It's just one part of the whole puzzle. But anyway, you can use it to drive a servo, for example, or in our case, you could use it to fade an LED. And if you want to do so, let's say you want to dim it to 50%, then in Arduino language, you would do an analog write with 128. But here it's a little bit different in MicroPython. So you specify the pin here, and then you pass it to this PWM object. And then you set the frequency, so how often it should turn on and off. And by specifying the duty cycle, which means how much of the available time is the pin gonna be turned on, you can specify how dim the LED is. And that's because our eyes cannot capture the turning on and off cycle. So you perceive it as dimmed. Cool. So what else do we have? Buttons as digital inputs, good old buttons. So we have a digital read, which we use in Arduino to read from a pin. And in most cases from a button or something else, you would use that. And in MicroPython, you can again use the pin object. So similar to what you use for the LED. In this case, you specify it as an input, and then you just read the value. So depending on whether or not you push the button, it would supply the pin with voltage, and then you would read either 1 or 0, which corresponds to high and low in Arduino language. There's a little bit more sophisticated way of reading from the buttons. I think we have enough time to quickly show that. So let me once again switch back to my screen here. Yeah, so let me fire this up. Button interrupt. Again, if you don't really know about interrupts, don't worry. The important thing is that the pins, if it supports, it can sort of figure out when voltage gets applied and when it gets sort of removed. So when the voltage is rising or falling. And you can do that by applying this IRQ function on the pin and then pass it a callback. And if I run this, let me run that on the board, then it enters this function here and reads again the value of the pin. If it's voltage, if there's voltage on it, it would mean the button is pressed. If there's not, it means I released it. So now I'm pressing it and then releasing it. Okay, now it did it a couple of times, but anyway, it registers these voltage changes, and that way you have like a little bit more sophisticated way of reading the button state. Good. Now back to the slides. And there we go. So there's our good old friend, the potentiometer, which allows you to sort of read, yeah, let's call it an analog value. So it can read sort of a range of voltages between 0 volts and your operating voltage. And to do that, you need something called an analog digital converter. And in Arduino language, this is called analog read. So you would read from that pin and it would spit out something between 0 and 1024, if I remember correctly. In MicroPython, you need to do it a bit differently. So there's ADC class here. So you instantiate an object of ADC and pass it a pin. But then it's very easy to just read the value from it by executing this read function. The U16 here stands for 16 bits. So what you get is a 16-bit value. We will see more of that in the demo of the MP3 player in a moment. The other thing that I used here was a rotary encoder, and that one looks very similar to a potentiometer, but it works very differently. So inside this guy here, there's kind of yeah, let's say a couple of switches, and when you rotate thing based on the voltage on these pins here, you can figure out in which direction you turn the knob. And you could do this manually if you want to, but as I said, there's a library for almost everything. So I chose the one from Mike Teachman, which is pretty good. So you just need to specify the pins where you have your encoder connected, and then you can specify also a range. Here I went for 0 to 10. So when you turn it, it would never go beyond 0 or 10. But you can also go for an unbounded working mode. I don't have that in this example, but it's also possible to do that. So we got that. So we almost have all the parts ready for our player. Bear with me. The other thing that I used is a LED bar module. It's actually not what you see here. It's not what you see in this picture. This is just the LED bar itself, but it comes with a LED driver. So mine uses this MY9 something something driver. And again, I found a library that makes it very easy to use it. What you need to do there is pass it the 2 pins where it's connected, and then by executing this level function, it will turn on a couple of LEDs. In this case, it turns on the first 5 LEDs. The maximum for the LED bar that I have is 10, so that will be the maximum value. What else have I used? I used also a OLED module, so an actual screen, which probably some people have seen also. There's, again, a library for that, and this one works a bit differently. So it uses I2C, which is a communication protocol that you can use to interact with components, with integrated circuits. So in this case, there's one more thing that we need to do. So you need to kind of tell it what kind of I2C bus it needs to use. So what kind of data line it needs to use. But it really comes down to specifying the 2 pins where you have the screen connected. And then you supply that object to the OLED driver here, the SSD1306. And then it kind of boots the screen and you can operate on it. In this case, what I need is just to draw a text on the screen, but there is more sophisticated functions to draw like circles and so on, or individual pixels, so you can do that as well. When you execute OLED show, it would draw the whole thing on the screen. Now, to put all of that together, as I said, it's a music player, so I also needed a music module. And I went for a DF player mini, which can be controlled via UART. And you guessed it, there is a library for that. I used one modified by my friend Ubi De Feo. So if you're here, Ubi, thank you for that. And it comes with a very simple API again. So there is a play function, a skip function, a previous track function, a volume modification function. So I used these functions in the demo. So now let's have a look at that. So if you don't believe that this actually works, I'm going to prove it now. Hopefully it does. So you should see again my screen. So let me fire this up again. Player combo. And I quickly want to walk you through this. So let's ignore this music player class for now because it's not really relevant. So I promised it's 100 lines of code, and here you see it's actually 100 lines of code. I mean, it's the glue code, obviously. If you would extract all of these libraries, it's much more, but that's what you need to write yourself. And here you see a couple of things. So it initializes the screen, as you've seen in the slides. It initializes the player, as also has shown in the slides. Same for the LED bar, same for the potentiometer, same for the push button, also for the rotary encoder. So what's really left to do is, in this while loop, which kind of corresponds to the loop function in Arduino, I read from the potentiometer and map this value. So I got something between, in my case, 170 something to 65,000, and I want to map that to something between 0 and 10. So I'm using this custom map function. And that gives me a level that I use as the volume level. So I fill the LED bar with that, and I pass it also to the player. So I multiply it with 10 because this guy here, it takes percentage. And then the other thing that I do is I check the rotary encoder. If it has changed since I last checked, I will check if it has been turned clockwise. So if the new value is larger, or if it has turned counterclockwise and would then change the track based on that and update the thing in the display. So let's run it and hope that it works. And this is maybe a bit hard to see, but here in the OLED screen, it says the current track. Now it says number 2. I can go to the next one. And that seems to work. So I'm going to post this code later on a GitHub repository. So don't worry if that was too fast, but we will have the chance to look at that in more detail. So before we leave this example, just to quickly wrap it up, there are these 2 functions that I didn't show before. So one is to read from the play /pause button here. And it does what you've seen in the slides. It just reads the value of the pin and then pauses or plays music accordingly. And the update display function, it just clears the screen and then writes the current track on the screen. So pretty much what you've seen in the slides. And as I said, all of that together in just 100 lines of code. I mean, I was impressed that this was so easy and it didn't take me very long to do that.
So Sebastian, I'm back in the stream with you at the minute. I think it's a good moment just to take a break because we have another survey that we wanted to share with our audience. We're going to pull up that survey now. And obviously we asked you to tell us whether you've had the opportunity to use MicroPython at all to date. And if you were able to say yes previously in the last survey, it'd be interesting to know what sort of use cases you found for MicroPython that work best for you. So we've got a choice between machine learning AI, OpenMV, IoT, or maybe some sort of other embedded development application. I must also say thanks ever so much for everyone's participation in the chat window. There's some great questions and back and forth and exchange. And also, I think a guy called Andy was also in there providing some feedback and sharing some links and information. So that's really good. There's some good questions. I think I'd like to pull up 1 or 2 of them just now while we're taking this break. For everybody who's asked a question, yes, the webinar is being recorded. We will be sharing it on YouTube later once we've trimmed and edited it, of course. And for everybody who registered for the online platform, we will be providing you information about how to access that later by email. Otherwise, simply go to YouTube and search for Elektor TV, and you should find the webinar listed there, along with the previous one from David, where he had that competition that he put forward for the Doom platform and controller. So I think we've got all our votes in now. We're going to end voting and have a quick look at the results. So we're sharing those results now. That there's a far large proportion of people developing IoT type applications and other applications than machine learning and OpenMV. OpenMV, I think, as Sebastian mentioned earlier, is also an artificial intelligence machine learning environment dedicated to sort of vision systems. That's its focus, and that's where it's started. But I think one of the things that we see here reflected in these results is the fact that MicroPython really is a good platform because of all the libraries that are included for handling IoT and communication type embedded systems applications. One of the advantages generally of MicroPython over just programming in normal C or C++ is the fact that string handling and things like that, manipulating XML files is much, much easier in Python because it's all sort of integrated into the environment. So against classic just sort of bare metal C programming of microcontrollers, MicroPython provides a lot of advantages. And I think as the examples that we've already seen as well, you'll notice that there's a lot of similarities between writing code in Python and writing code in normal Arduino. One of the questions I had for you, Sebastian, we'll jump into this. If we go into the Q&A, just pull that up. Someone's asked, can I take existing Arduino C++ code and compile it into a C++ based MicroPython module?
it's not as easy as just compiling it into it, but you can create something called bindings. So you would compile it in a linkable way, and then have those functions exposed in MicroPython. So yes, you can do it. It takes a little bit of work, but it's definitely doable. Another thing, and maybe I should not say that, but I tried recently to port a library from C++ to MicroPython using ChatGPT, and it was actually pretty good. So that's another way of doing it these days in 2023.
Exactly, a very modern approach to MicroPython programming. Super. There's another question here from Tanvi. They've asked, how would the programming differ between what you showed us for Arduino and say a non-Arduino based platform? Are there parts of MicroPython that are common amongst all microcontroller boards, and are there parts that are different, maybe because the hardware implementations are different?
Yes, good question. That's actually the beauty of it. So I would say generic answer to this, it wouldn't differ. So what I have shown so far, it's the standard API. However, for certain ports, which means for certain boards, there is sometimes some custom functionality that is just not available on all the boards. And in the documentation, you would see that. However, the majority of things that you need to use are the same for all the boards, so also for non-Arduino boards.
Super. And then there's also this question here as well. What's missing from MicroPython that makes it a subset of Python? I think you covered that in one of the slides, but maybe just sort of reiterate the core difference between Python programming on a PC and Python programming or MicroPython programming for an embedded microcontroller.
Yeah, I don't have it on the top of my mind, but it's a certain, let's say, modules for computational intense algorithms. They just don't really make much sense to run them on microcontrollers, so they strip that away. Yeah, but you can look it up. It's actually well documented on the micropython.org website. So they removed the things that they thought didn't make sense on the microcontrollers, and that way allowed to run it on such limited hardware.
Super. Okay, well, thanks. We're just for that little break there in the presentation, and I'm going to take you back to the presentation now, Sebastian. You can take us through the last two stages and the demos you prepared for us.
Right. So looking at the time, I think I will keep those slides here brief. So some of our boards, they have onboard sensors, and you may ask yourself, how can you use those? And the answer is it's very simple. To use them the same way as you would use connected sensors. In most cases, these are I2C modules, which means that you connect to them through a bus. And the only difference is that, for example, here with the RP2040, it has this IMU built in, and you don't have to download and install this library. It comes with the firmware. So you don't need to worry about that, but the rest looks exactly the same. So that's really cool. So you can use this library here, for example, to read from the onboard accelerometer and from the gyroscope. Then another cool thing that I briefly want to talk about is timers. And we've all been playing with millis and comparing millis to other timestamps. And we've all probably have, had some bugs because we got it wrong. There's let's say an easier way in MicroPython to do that, which is timers. They work a little bit differently, but the way you can do that is you can set up an interval timer, which you see on the left side. So you instantiate a timer object, and then you initialize it with a period time of, here it's 250 milliseconds. And in the callback, you tell it what it needs to do. So this example here would make the LED blink at an interval of 250 milliseconds. And then on the right-hand side, if you just need a one-shot kind of timeout timer, you can do the same. It looks also exactly the same except of the mode. So you pass it there a one-shot work mode. And in this case, after 4 seconds, it would turn off the external LED. The only thing to consider is that this stuff runs in some sort of interrupt-based context. So you shouldn't have extensive callbacks, so keep them small. Do not allocate memory in these callbacks. Other than that, they're super useful. Then that's something that I have to mention, because I said that it lends itself, MicroPython lends itself to do Internet of Things applications. And one reason, in my opinion, is that it has built-in JSON support. And also there's this socket class that you can use to actually fetch data from the internet. So let's imagine here that we have this JSON data downloaded from some web API, which would give you the temperature for a specific date. So all you need to do to access that in Python is you pass that data to the JSON loads function, and the S here stands for string. And when you do that, it translates it into a Python object, which you then can use as you would do normally. So here I'm looping through the different dates. Here it's just one, but anyway, looping through the dates and then print out the weather for that date. Very easy to do. It's built in, so no need to install a library. Super cool. Then another thing that I want to talk about, because it kind of goes along with that, is the Arduino IT Cloud platform, which is a platform that we made to connect your devices and to visualize their data and to interact with these devices. So you can create your dashboards and visualize data, and then control your devices from wherever you are. Now, we haven't really been looking into IoT Cloud so far with MicroPython, but recently we tried to see how we could make that work, and we got a proof of concept running, which I'm really excited about. So I have some demo code here to show how that works. The end result is sort of a dashboard that shows sensor values, and in my demo I have attached a BME 680 sensor that gives me humidity, temperature, pressure, gas, and so on. So that's what you see on the right hand side. That's what I want to display. But you could use IoT Cloud for other things. I mean, it's reading sensor data, it's recording the history of sensor data, but you could also send messages. It has this message widget that you could use, or you could trigger action. In this case, I have a button that allows me to turn on or off the LED on the board, but obviously you could attach any machinery to your board and control it that way. You could turn on or off your oven or a lamp or something else. So very cool. And another cool thing is the Arduino Cloud CLI, which is a small tool that we made to set up these projects in an easier way. So usually you can use the web UI to create your things, and we call a data container in IoT. We call that a thing. So it contains different variables, different properties. You could do that with a UI, or if you already know, or if you already have sort of the structure, you could use a template. And I made one for you, so I'm going to upload that later on to this repository so you can try it yourself. On the right-hand side, you see the preview of such YAML file. So it contains the different properties and some parameters for it. And when you run this tool, it creates that automatically for you. And the same applies for dashboards. Also made a template for you to try it out yourself. And there you just need to basically tell the dashboard which thing it should attach to. So you override the thing ID, and that's all you need to do. You actually don't even have to do that. I wrote a shell script that puts all of that together. So you only need to attach your device in the end. So let me quickly show you how that works. Application window, Arduino lab. Okay. So let me paste. No, actually, let's create a new file here and paste some code. The code doesn't really matter so much. I think what matters is that I connect to the Wi-Fi, and then when I'm connected, I would register a IoT Cloud client that sort of ensures the data synchronization. And then here I have a couple of properties that get exchanged. And if I run this, then Takes a couple of seconds. Oops, connected to the wrong board. That one. Okay. Is it doing something? Maybe, maybe not. Okay, now it's doing something. So it's connecting to the Wi-Fi here and connecting to the cloud. I should probably share the whole screen so you can see also the dashboard. Okay, so you could see in the log here that it has output a couple of properties from the sensor. And if we're lucky, then we should see here that reflected. Now you see the changes in temperature. If I breathe at the sensor, it would probably increase the humidity and also the temperature. I would assume it takes a couple of seconds to upload, but at some point we see it reflected here. So very cool, we got that to work, and super nice proof of concept. So it looks like this works just as fine from MicroPython. Good. Then back to the slides. We have a couple more minutes left. Okay, let's see how much we can tackle in that amount of time. Stuart, how much time do you want to allocate for the questions?
There we go. Yeah, we'd like to have about 5 minutes at the end. We probably can on the top of the hour for those who can start, carry on.
Okay, no worries. No problem at all. Okay, then there's OpenMV, and meanwhile I'm connecting yet another Arduino board. So hopefully I can show you some last demos or demo. OpenMV is, as I mentioned, a specific IDE that allows you to do machine vision in a simple way. What is machine vision? It's basically the process or the automated process of inspecting an image and analyzing it to do process control, maintenance checks, robot guidance, whatever you need. So you analyze the objects and then extract some information about them. And this is in sort of opposition to computer vision, where it's more about understanding the entire context of an image. Now, I'm not going to go into too much detail on the IDE itself, but I want to show you a couple of cool things that you can do with it. One is blob detection. So you can detect let's say, blobs of pixels that differ in properties such as brightness or color. And to do that, you can define thresholds for these values. And I'm going to first go through the features, and then if we have a bit of time, show you real quick the demos. Another thing that's really cool in OpenMV is frame differencing. So you can take, if you let's do the example here. So if you want to figure out where is this bus, in the top right picture, there's a bus, and then there's a street from my apartment here. And if you want to figure this out, you can do it with blob detection, but it's a bit difficult to extract just that, because yes, it has a white roof, but then there's grayscale like side panels, so it's kind of difficult to distinguish that from the surrounding. So what you can do instead is that you take a still image without any traffic in it, and then subtract that from the original camera image, which would leave you with what you see at the bottom. So it's just the bus. And then you can apply blob detection on top of that. So then it makes it very easy to run this blob detection, because it's just black background with some gray, white-ish pixels on top of it. Another cool thing that you can try out yourself is object tracking with April tags. It's a very reliable way of sort of tracking a thing as it moves. It's a little bit more tricky to do that with blob detection, but April tags allow you to do this at more than 30 frames per second. So really cool, super fast. And you can get also the rotation of an object, which is really cool. So if you want to do any project where you have things moving in the environment, then April tags are a super good way to do that. And let me just take one more minute to quickly show you these things. in OpenMV. Then we'll take some questions here. Here we go. So here's the OpenMV IDE. Yeah, I'm not going to explain much about it, but there's a camera preview on the right side, and on the left side there's the code. And you could see that the blob detection really comes down to just one line of code where you pass it thresholds, and then it will try to find these color thresholds in the camera image. So let's quickly do that. So now here's my camera, and here is a black thing, and I'm looking for blackish kind of objects. And you can see that as I move the camera, it very swiftly updates the viewport and finds the object. So it's really easy to do, really just one line of code, maybe 2 lines of code, and by defining the thresholds also. The other thing was about the frame differencing. You kind of saw the code a little bit already in the slides, just to show how that looked like in the end. So you would be able to really detect a moving object in a still environment. So subtracting a still image from the camera image gives you the sort of target image to work with. And then last but not least, April tags. Let's see if I can quickly show that also. So I have it on my phone, didn't really get to print it out, but you see that here, when I turn the phone, it would indicate the rotation of my phone. And it does that very fast. So now I only have 21 frames, but sometimes it gets up to almost 40 frames, depends a bit on the data. So really cool stuff. Now you have a couple of options that you can try out if you want to do MicroPython, because all the OpenMV code is in MicroPython, and they support the majority of our boards. So if you happen to have one of those, give it a go. There's a, let me quickly show in the slides. There's a link. Can you get the slides back? Yeah, no, okay, we can take the questions. Anyway, there's on the last slide, there's a link to the place where I'm going to upload the code that I have shown, and there's the docs website, and specifically here, the MicroPython documentation. You can find it there. So yeah, thank you so much, everybody, for joining, and the ones who can stay a few more minutes, I'm here for questions. Bring them on.
Super, thank you ever so much, Sebastian. That was fantastic. We've had some great commentary in the background here, and I've been doing my best along with the rest of the Elektor team to guide people to some resources and answer some of the questions directly. It's a good opportunity, though, to pull up some of those questions that appeared during the show that we didn't already cover. I think one good question is, here we go, there's this question here. What is the RAM/ROM size that the MicroPython runtime needs on a microcontroller? So how much space is maybe left for my application?
Yeah, let me quickly look it up here, because it really comes down to the firmware size. It depends on the port. So for example, on my RP2040, it contains a couple of drivers that maybe are not there in the bare bone one. And that one is, what is that? It's not even a megabyte. So it's 800 kilobyte. That one is 1 megabyte. So roughly 1 megabyte for an RP2040. And in terms of RAM, you could get away with just 8 kilobytes of RAM. But if you want to do anything meaningful, you should probably have a little bit more than that. So it runs on very, very limited hardware. But if you want to do it use it for anything practical, you need a bit more than that.
Yeah, super. Someone's also asked, is it possible to use VS Code as an IDE? Have you seen anyone doing that? And yeah, is it sort of easy to move from the Arduino environment or OpenMV to something else?
If you don't need any camera preview or any other bells and whistles, then I will say yes. I'm pretty sure there must be a plugin already that facilitates sort of the communication with the board and the IDE over this REPL thing that I showed you. So that's the way kind of to communicate with one another.
Okay. There was a question also about your audio player example. Is those audio tracks you were playing, are they on an SD card or are they from a web connection? Where do they come from?
In my case, they're on a micro SD card. I think it's probably a bit of too much data to really fetch that stuff from the internet, but
yeah,
probably doable.
Okay. And also on that same topic, I mean, how much do we know approximately how much memory that application took in the microcontroller?
No, actually, I don't know. I would need to figure this out. The good thing is the whole sort of music processing happens on the module itself. So on that end, it's probably very, very little memory that it takes for that.
Super. At the end of the day, I mean, the application you wrote is just a plain text piece of code which is interpreted, isn't it? So the application you wrote only takes as many bytes as data as the number of characters in the code. That's correct, isn't it?
I mean, it will allocate. So because it also imports a couple of libraries, and it's not just about sort of interpreting that, but it's really allocating objects and hence memory. So there is there's a little bit of memory footprint involved, plus the whole MicroPython runtime, which kind of builds on top of that.
Yeah. Now, one of the when we write code for a normal Arduino board in C, C++ and use the libraries, all of that gets compiled by the compiler, and then a binary gets downloaded onto the device. But with MicroPython, what we're doing is uploading our text code of the code onto the board, onto the microcontroller where it's interpreted. So is there a way to protect that code from being copied by somebody else? Is there any mechanism for that currently?
Well, the other thing that I know that you can do to kind of make it at least a little bit more difficult is to cross-compile it, or to upload the bytecode. So you don't upload the source itself, but the bytecode, which you can still decompile, but you would not really get the actual source code out of it. You could still figure out what's going on, but it doesn't allow you to just copy paste your code. So that's something you can do. Actually, a lot of libraries, they come in this bytecode because they take a bit less space in the flash.
Yeah. Excellent. So that covers a few questions that were similar as well. So thank you to everybody who shared those with us. What else is? Yeah, the other question was, what is the ID? This came up from Jorge during the last section. So maybe you could just tell us that with the I think we were looking at the image interpretation and the blob detection. What ID were you using there?
Maybe, I'm not sure. Does the question is which one I used or what is an IDE? So it stands for Integrated Development Environment, which basically means a tool to use for programming. I've been using the Arduino lab for MicroPython for the initial examples, and then for the machine vision stuff, I was using the OpenMV IDE, which you can download for free, and it's actually most of the code is open source. You can find that also on the GitHub repositories. Yeah. Another great open source project to support. Great.
There's another question as well. What's the sort of memory requirements for an OpenMV type application? Does MicroPython using OpenMV use a lot more memory than an application without the image recognition capability?
So the OpenMV firmware builds on top of the official MicroPython firmware. So you could probably figure out what the runtime takes up in terms of memory footprint. But I think the significant thing in memory is going to be your the camera image, and that's also why you need to sort of figure out what kind of resolution you can go for. I mean, you can do the math. It really depends on the image that you get from the camera. I think they have some compression built into OpenMV, but if you have, let's say, VGA resolution, that takes up almost all the memory. So depending on what's left in memory, you probably have to go down in resolution.
Okay.
But I don't have the exact number.
Yeah.
In terms of requirements.
Super. While we're on the topic of IDEs, someone Hussein is asking here about the whether it's supported on the Mac M1 computers? Are the IDEs generally supported across all the Apple range of computers?
Well, for OpenMV, I can't really tell. I'm not fortunate enough to have one of the newer models, but I know for a fact that a lot of people in the company have that, and for sure the Arduino lab for MicroPython should work on that, and I haven't heard any complaints, so I would assume that also OpenMV runs with the newer Mac models.
Okay, super. I seem to have lost my camera there for a second, so I'm just going to see if I can wake that up again.
Turn on a flashlight.
Yeah, exactly. I'm not quite sure what happened there. Supposed to stay on for a while, but decided not to. There we go. Great. One of those things. There we go. Hopefully we're still in focus. There, back again. No, completely out of focus. So yeah, we'll just have to manage like this for a second. Not quite sure what's going on there. There we go. Super. So I think we've got more or less through most of the questions. There's obviously many more questions. So thank you ever so much for joining us there. I'm just going to try and adjust that for a second.
If you have any more questions that you want to ask me directly, there is my email address on the last slide and also my LinkedIn handle. So please feel free to reach out to me. I'm happy to chat.
Excellent, super. I'm just this is my little tool for focusing in my video. It's my replacement me for whenever I'm sick. So there we go.
Nice.
Yeah, that's the magic of TV.
Can't really see any difference.
Of the studio. Yeah, exactly. It's exactly the same yeah, technical support that you get from me in person. Super. Well, thank you ever so much to you, Sebastian, firstly for joining us today and providing us with all those examples and introduction to MicroPython. I think it's very exciting. It's also yeah, let's say it's very different. I think someone like myself who's grown up with microcontrollers and C programming, obviously it's a different approach to programming, and also it's for different purposes. But I think one of the things when I was talking to you, we did that interview in the magazine. That was issue 518. So for those of you who want to have a look again, that's the December-January Elektor magazine. There's the article there with Sebastian. One of the things that came out of that was really MicroPython is really establishing itself in areas where people are using Python on PCs to develop IoT applications, to developing machine learning applications, and they want to stick with Python as a programming language when they move to the embedded environment. So that's a sort of a growth area for MicroPython, and one of the reasons why it's quite popular in that respect. So it was a great chat that we had there. So thanks very much. Thanks also to David for answering a few questions at the beginning and joining us from Sweden. That was fantastic too. Thank you also to our audience. We really appreciate everybody joining in today and for the great exchange and discussion on the forum there in Click Meeting. There's a link at the top of the page now which will take you to the Arduino documentation. Don't forget, you've also had the giveaway information. We've shared that a few times, and the code word was snakes, as in the Python snakes, not as snacks, which maybe was misheard as I was speaking it earlier. So feel free to join in. There's 5 great giveaways there. We've got that machine control PLC controller, we've got the Arduino Nano, we've got an RP2040 Connect, Portenta H7, and a Nikla Vision. And yeah, delve around and explore, because there's some great stuff going on there. Machine learning has become much easier to implement, much easier to play with, because there's such a strongly established basis upon which you can put your ideas over the top and explore and discover. Elektor will be at Embedded World in Nuremberg next week from Tuesday to Thursday. That's right, from the 14th to the 16th. We're going to be in Hall 4A, stand 646. That's 4A 646, and we'd love you to drop by. The Arduino team will also be at Embedded World, walking around the show floor. So if you want to chat to any of them, you might bump into them in the corridors and gangways between all the stands there. And thank you ever so much for participating and joining us today. The recording will be available on YouTube afterwards. Everyone who's registered will get some information about that to see it again later. And yeah, we look forward to having Arduino and the team back on the webinar in future. And otherwise, feel free to join us both on YouTube at Elektor TV, where we cover all of our lab talks, webinars, all our updates about the projects that we cover in Elektor. And also on YouTube, we have Elektor TV Industry, and that's where we cover our industry news and our industry interviews with people covering things like RISC-V, automotive development, new microcontrollers, displays, and everything else that's going on that all feeds in to the maker community and makes those chips available that you can connect to Arduino boards and extend them in order to do these fantastic applications. So all the best with your development ideas, thoughts, and share them with us once you've got them there. We'd love to put them into the magazine, onto the website, and share them with the broader community. Feel free just to get in touch with us at the Elektor team. All the information's on the website, elektormagazine.com. And yeah, hopefully we'll see you in our next webinar. Thanks, and see you soon.